Thank you everyone for being here. To get started a little bit, maybe with some context, I wanted to, as I'm coming here to FrOSCon, I was talking to my employer, go think about how I'm here, and we thought it could be interesting that we talk about the fine work we're doing with KDE in there, and BuildStream and Free Desktop SDK and all of that stuff. All of this work is happening under the umbrella of KDE Linux. If you were in my presentation earlier, you maybe got a little bit an idea of what that was about. I'm going to go a little bit more in depth in here. But also, like, other topics in that, like what we're discussing is largely build systems and how to make sure that you can provide good binaries for your users and make sure that they are happy consistently across the board. Before we go deep into the topic, so that you can contextualize me a little bit, my name is Aleix Pol. I am from Barcelona, but I'm living in Berlin since a couple of years ago. I have been a KDE contributor for the best part of the last 20 years, and I am also part of the KDE as a member, but also the president of the KDE board. And I am employed by CodeThink since last October, where I've been learning a whole lot about build systems, BuildStream, and so on and so forth. And I also do a Twitch stream every Sunday. Actually, I do it every Sunday, more or less at this time, like from 6 p.m. to 8 p.m. You're more than welcome to join. Obviously, this week I'm not doing it because I will be on a train back to Berlin, but otherwise I am there together with Harald, who is also a long-time KDE contributor and one of the authors of KDE Linux, and we talk a lot of KDE nerdy things that I'm sure you all would super love, or not, but you can do it from your couch. So win-win, right? Now, to give a little bit of context to all of that, let's start thinking about KDE Linux. KDE Linux, what is it? KDE Linux is an operating system. Linux is a Linux distro. This is not what we've historically have been doing from KDE. Historically, what we did was give our source code to other parties, and they would produce things that would eventually reach users, and users would love it. And now what we're doing is something slightly different. Now we're taking our own source code, producing these binaries, and having this direct report to our users and giving it to them. Now, this is the operating system, as in the shell, the kernel, the dependencies, and all of that stuff. Then we have the apps and all of the things that you can install outside of your operating system, which we're also producing. We're producing a bunch of apps. We're also producing a bunch of frameworks and stuff. And there's also other ways that you can end up doing all of that. And the smart of you folk will say all right, you're talking about how you were doing way too much work already, and now you had the marvelous idea of how about we do even more work? Isn't that fun? And yes, effectively, that's more or less what's happening. As software, largely graphical software, actually, people were moving into creating operating systems and delivering it to our users, and there's good reasons for that. I'm gonna try to make sure that you understand them, because I think actually it's kind of interesting and important in the context of why and in which cases KDE free software works, and how we can make sure that free software can actually prevail, right? So a little bit the idea is that KDE has been working on a direct rapport with the users. We create things that they interact with very much directly. And it's very important to us that this rapport is both bidirectional and actionable, right? As KDE, we want to be able to not only have the concept of how a good Linux free software, how a good free software operating system can work and can interact with the user, but we also need to be able to give it. Otherwise, we are getting ourselves lost in that conversation with our users. And why is it important that we do it? Because we want to be able to care. We want to be able that when one of our users has a problem, we want to be able to react to it. We want to be able to say, all right, you had this problem. I'm going to, well, see that the problem is real. I'm going to address it, and I want to be able to give it to you in a well, working way, which is kind of what this all is about. The status quo wasn't really working for well, in its entirety. And thus, we started working on this big project. Now, let's take a little bit a step back. What I want to talk about this in this presentation is not so much about the end product that we're creating. And I'm sure we're going to have like good talks about that in future events of FrOSCon. What I want to talk about is how we're suggesting to build this in a way that it makes sense, and it's also not adding a big burden on our already stretched out community that is going to make it way too hard and, well, implode somehow. So I was saying that historically we were not really producing that many binaries. We were simply like putting out a bunch of source code for others to package. That's not entirely true. We already have distribution called KDE Neon, which was something very, very similar to what we're doing in KDE Linux, and largely for the same reasons too. And it's worked somewhat well. It hasn't worked well on all of the fronts. And it has also a number of limitations that we don't really see how to address at once. So like this project keeps going, and it does have thousands of users. So let's not like dismiss it or say, well, it's gone, which is kind of how some people see it. It's there. We will see how it works. If there's people working on it, it's going to continue. But it's there. And it's something that we still like is already building our software and will continue doing so. We have KDE Linux, which we discussed a little bit as well. And then we have Flatpaks and Snaps, which are mostly applications. And actually, Snaps is not even, it's even more than that, because you can produce a whole operating system from a snap kind of thing. But yeah, like you have also a bunch of binaries that go from well, a tiny app to a more complex thing. And if you were in my presentation earlier, you will also have seen that we are on other operating systems because we make a bunch of applications that are also useful elsewhere, be it because like you simply want that functionality, like the example of Krita I showed there. You might want it for sure on other similar devices that run other operating systems that will have similar features. Like if Krita works fine on Linux, it's also gonna work fine on Windows and Mac OS, which is what many people use. And being where people are is super important. So those are also binaries that we're generating, and we have to, because people will want to test them, people will want to use them, and people will want to, well, also like have the problems, address them, and all of this story I was going through before. It's on the table. And then we have the CI and CD, and we have many of them. For every change we do, we build them for like different distros, for like SUSE, for Alpine, at times for Windows or Android as well, depending on like the different product will have different audiences as well. We're carrying off all of them. And if we take a more specific look at what we do for Linux, because, well, we have a lot of tooling needed for this. A lot of the proprietary operating systems will have their own tooling, and this is not something we want to address in here. What we're talking about here is Flatpaks. We're, for example, using a tool called Flatpak Builder that will run the format of Flatpak and produce you the binaries for the app, for example, right? On KDE Linux, what we are still doing now, although we are in the process of transitioning, is using Arch Linux binaries and simply putting it there and then building KDE on top, or using our KDE Builder, which is a tool, a script that we have in KDE that you can use it to create your development environment, and thus the environment that the user is going to use when he's on KDE Linux right now, right? And for the CI, we have also other custom tooling that will do this building and such. So even in those narrow concept here, we already have many tools and systems that are interacting with each other and are, well, largely different, right? Like for Flatpaks, we will have a different, well, its own manifest file. For Arch Linux, we will have its own. For the CI, we have, well, different files that include the graph of dependencies and stuff. So there's a lot of metadata that is already in place, but also that is in different parts. Another aspect is that all of the Arch Linux binaries will be controlled by a third party. So if there's a problem in one of our dependencies, it's not super actionable for us to address it, right? But there is an opportunity, or we need to find an opportunity where like the constraints are, right? We are talking about people using hardware, which is expensive. We need to be able to well, be on top of it, right? We have a lot of complexity. We are talking about modules that interact with each other, and then you need to integrate them together. And actually, like the people who know how to integrate it, in the end, they are within our community. Like whoever has, like everybody can learn from what we do on the outside, and obviously they do a very good job. But it's the people who have been developing the things who will know how the different components interact in any case, right? And then developer experience is something that is hard to get right. And we need to make sure that we build on a new technology, or a new technology. We need to build on a technology that is going to help us establish that one right. And this is something that, for example, when we tried doing it on KDE Neon, it wasn't super clear how to do. What we have been doing in KDE Neon, for example, is like you build all of the dependencies locally, even though you have them already coming from the distro, from the in the right version, but you need to have all of the files inside. And well, it's hard to get it right in any case. So we started looking at the FreeDesktop SDK, and the FreeDesktop SDK also was a technology that we had been using since many years ago. The FreeDesktop SDK is what we base our Flatpak runtime. So we've been mostly talking about operating system kind of thing so far, but for apps, we mostly have been using, or for one of the ways to get our apps in any case has been Flatpak. And in there, like we produce binaries for all of the applications, but also we put forward what is called a runtime or an SDK, which includes all of the dependencies for the different applications and the tools that the developers are going to need to be able to develop them. And well, the one that we are creating, which includes Qt and all of our KDE frameworks, is based on FreeDesktop SDK. FreeDesktop SDK is a set of components that are part of any of the Linux distros. It's a toolkit that's also already used by not only other Flatpak runtimes, but also different operating system projects around the world that want like a tooling that is befitting them, right? And well, at some point, we, with a work colleague, we had this idea, this thought of how about we start building the KDE SDK using BuildStream, which is the tool that is already used to create FreeDesktop SDK, instead of using the Flatpak builder, which is the one that we use for apps. Actually, this is something I had been thinking about for a very long time. I started the Flatpak builds in KDE around 2019 or so. And since then, actually, FreeDesktop SDK more or less started also using BuildStream. But I was thinking, OK, we're already maintaining all of the applications using Flatpak Builder. It makes sense that we also use Flatpak Builder to maintain this SDK, which is something that all of the applications will have a rapport with. And it's good that if somebody knows a tool, well, knows the other. But here we started thinking about it the other way around. How about instead we use the same tool in the SDK as we use underneath, and then we can start like reusing more of that stuff. One of the big aspects here as well is that BuildStream is much more developed than Flatpak Builder is right now. So we can come up with a more solid base. And also it has more tools, right? Like Flatpak Builder will be generating the binaries, but you don't have a lot of ways of saying like, let's debug this small component here or things like that. Right? So yeah, we started using it so that we can use the same toolings for our runtime and the runtimes we depend on. But also it means that other projects, not necessarily Flatpak runtimes, but also maybe can decide to use the modules that we have for BuildStream into their projects. What do I mean by that? What I mean is that so Flatpak Builder manifests are a humongous file for the most part. What we have in BuildStream is mostly smaller parts, like every component, so to say, will be a separate file. And then you can say from another project, well, I am this application and I want to use Qt. How about you look at this other repo in the other place and like get it from there instead of maintaining my own, which is good because like us as KDE, we've been doing Qt and things since forever, so I think we can be trusted on that. And then all the other advantages, then like we're moving what we create on this other ecosystem. We can leverage all of the tooling they have, right? If it's a tool that is being used to create operating systems for the industry, for like many weird use cases, and for very different also kind of developers, we will have tools that are slightly different as well and interesting, and we will see maybe a little bit what they look like. So the first step I took was to create this SDK, but in BuildStream. What I did was actually to create a script that would take the JSON we were coming from and create the YAML files that BuildStream consumes, and that worked. Actually, that took a week, if not less. And then we said, all right, this is working already. How about we do the same with Plasma? And actually, we already had a Plasma Flatpak recipe, which we're not really using because of other technical limitations, but in this case it just worked. So at the end of like maybe a couple of weeks, I already had a Plasma running on this BuildStream, which soon enough turned into a virtual machine that you could boot because FreeDesktop SDK, other than the SDK part, also would have like the kernel, the systemd, and all of the system services that you need to have a useful operating system. So the next step was either like, all right, cool try, let's go to sleep, or how about we try to take it to the next level, right? So what we started looking into was how about we leave KDE Linux as it is, but instead of getting all of our binaries from Arch Linux, we start getting them from BuildStream. And let's see how it works. And it worked, right? I was talking about weeks time until I was more or less like this. That was maybe a couple of months later, but it ended up working and it was pretty cool as well. But it gave me some like excuse to go to Harald and the other KDE Linux people and say, how about we use a tool like that can allow us certain things. We did also some like weird tests. For example, this sounds silly because it's like a Plasma inside of a bigger Plasma. But what we're seeing here is already like an ARM64 emulated QEMU inside of my development device. Like you can see, that's my desktop computer. So we said, it's working on ARM, but like it's kind of sad if you have it only in a tiny window where it's like simply only slower because like it's emulated. So we ran it on a piece of native ARM hardware and it worked. Here you can see it's a bit weird because I build still Plasma Desktop instead of Plasma Mobile, but it's a matter of like building the one or the other, right? Like it just works, and actually it works super well. This is the Fairphone 5. Good piece of hardware. And that was more or less when we said, all right, like this is like proof of concept is done, right? Like we can do, actually, by then we could do more than we could do on Arch Linux, because on Arch Linux we never really tried to do ARM. So it was mostly about let's polish and see how we can take it the next step, right? So how do we explain, or how do we tell ourselves that this sounds like a good idea, right? One of the big and useful advantages when using BuildStream is that you can cache builds, which sounds a bit silly because we're talking about like moving from Arch Linux, where like you not only cache builds, like you're only getting binaries from them, right? Like you're never building their packages, or you don't really need to. But it's very important because like big part of the reason why you want to have and use a different tooling is because there will be like you will want to take ownership over certain components that are coming from elsewhere, and you don't want to like have things building all the time. Also, there needs to be a lot of building that needs to happen on KDE Linux, and more or less the idea is that this would become part of the developer experience, right? So let's say you are a developer of an application, you want to modify a dependency. You shouldn't need to rebuild everything up until where you want to develop. You can simply download the assets or find them already in your system and work on top of them, modify what you care, edit, test it, and then submit your change without having to, well, like spend an iceberg worth of energy to get there. Another thing that I think that is super important, and we have largely failed at in Linux, with the exception of the post-Market OS folk, is looking at ARM and RISC-V properly. These are systems that are much less standardized compared to what we're used to on the Intel world, and well, we need to be able to target these systems. BuildStream is already, and FreeDesktop SDK is already prepared for these systems, as like that's also much more common in the industry than on the community and the personal computer world, so that makes sense. And then FreeDesktop SDK and GNOME, like they are already using FreeDesktop SDK, so we might as well share it. And I only said GNOME, like GNOME OS is also based on FreeDesktop SDK, but so are all other operating systems. There's one called Dakota thing. And there are increasingly, there's also projects, well, there's industry projects from our company that I cannot really disclose, but you can believe me that they're there. There's also, like, it's increasingly becoming a good solution to use FreeDesktop SDK to create your container binaries, right? And yeah, like having all of us work together and produce central things seems like a good idea, right? Now, what I would like to reflect a little bit is on how all of these changes, like I am talking about here like quite normal things, like nothing is super out there, but I am certainly talking about things that change how we operate at a community level, not only in KDE, but like also within Linux and within, well, that train that goes from the end, between the end user and the developer, including hardware manufacturers, hardware assemblers, and so on and so forth, right? Like, for example, integration or testing for integration right now looks vastly different to what it looked like before, right? For example, when we were thinking about that in the distro world, what we were testing was our opinion of Plasma, for example, or our application. But then the different distributors, they needed to well, think about integration and well, test for it, right? This is largely changing. And actually, this is a project that has already been executed. There's a system on our CI right now that, well, boots and tests things in of KDE Linux images. So we can be sure. Like, maybe I haven't gotten like super into this, but big part of the idea of creating your operating system is to, in an operating system much like KDE Linux, is that you want to be able to test your system and make sure that your test reflects to what the end users are going to see. KDE Linux will be or is an operating system based on images. These images are not modifiable by themselves, so your experience should map one-to-one to what the user is using, as long as the hardware is compatible, right? And why is it important that we use a tool like BuildStream? Well, we are talking about having to rebuild things. We need to have a tool that where it's the developer who is creating that experience, to creating that solution, who gets to like put the things where they need to be, and then execute that QA. And it's doing a lot of the things that we need, right? Like they already prepare for reproducibility, for example, for delivering at a scalable level, to share infrastructure. Infrastructure is super expensive, especially these days. And you need to have tools that have thought about all of these topics from a global perspective, rather than simply how do you run and execute a build locally, which you can always do, and we have done that forever. But yeah. And then another super important part is that there has been people thinking about developer experience or a version of it for BuildStream, which is not something that we would have. Like, we had the developer experience thought around KDE Builder, but it was specific to KDE Builder, and we had maybe tooling for the different solutions, like, for example, for KDE Neon at the distribution level, but they were always somewhat dissonant. And what we were thinking about is like seeing how we can marry these two aspects and like maybe have a solution that is good for the both of us, because in practice that's kind of what we need, right? Like, we don't want to have, well, two stories that are incomplete. What we want is to have one that works. This is more or less a little bit what it would look like for a developer who wanted to modify something in their operating system. To, again, it's not to modify because you want to have something slightly different. It's modifying it because you want to develop or fix a bug or something like that, right? And one thing you can do, for example, is using the BST workspace tooling that will, well, get whatever asset. Let's say we have Kio. Kio is one of our frameworks. You can tell it, like, put it over there. It's going to use Git to fetch it. You can modify it. You can use the Git tooling that you're familiar with to modify it, to address it. You can even create a merge request from there. You can build it. You can try it on your system using sysext, which is the whole thing. It's not ideal just yet, and we are thinking about how to do it right, but it does sound like it's somewhat part of the solution, which I think that is somewhat exciting, actually. And then, yeah, there's many toolings. Like, we also have BST shell. So what I was talking about earlier was the reproducible builds. You're never going to do a reproducible build in your system as long as, like, it's your system as you see it, right? What BuildStream does when it executes a build is create a container in which only has the dependencies you requested, and then over there you have the build. So you can ask the tool to give you a view on that container and interact with it to see exactly what was happening in there. So yeah, you have that oversight. I do think that if we need to address ARM and, as I was saying, RISC-V, although I think that RISC-V is already doing things slightly better than ARM, we need to have the tooling that will be able to solve them. We cannot say ARM needs to fix so that our way to create distros work, because we have seen that they don't really care that much. And also we cannot be reliant on others fixing our world for us to be able to service it. Like, we want to be able to have free software on every piece of hardware tomorrow, if not today. And yeah, we need to have tooling that works for that. We're also exploring, like, we already brought BuildStream to our SDK. We brought BuildStream to KDE Linux somewhat. We're talking about how about we use it on apps. It's still slightly unclear how we're gonna work it, because I do think that the format that BuildStream is using is not yet ideal for applications, but actually it's a conversation we can have. It's a software project, we can contribute to it. If things don't work, we can create other tools on top. And actually this is something that I have been looking into and thinking about. And hopefully, like, soon enough, I'll have a good answer for it. But yeah, like, Free Desktop SDK is becoming industry-wide foundation, foundation where other projects, other operating systems can come and base themselves on. The more we have, the more tested everything will be, the more easier it will be to maintain things. At the moment, like I was saying, we have been using generated components for the SDK. We're going to start actually establishing them for KDE Linux. A little bit the idea will be to have them also used for the SDK, like handwritten, and then we will maintain this. We're thinking about how to have tooling that then will upgrade them automatically. If you look at our GitLab, you will see my merge request already with that tooling. We will see how that will work, but I think that it's somewhat exciting. All right, that's that topic. But yeah, being part of that ecosystem doesn't mean like we get to use things for free, which is cool, but like not the things that you can use, but there's all of the ecosystem around it. One of the big topics that we've been discussing earlier on my other talk in the Q&A was CRA, and actually like being able to provide all of the meta information around the project. Well, having a tool that is designed to be able to provide that is super important, and this is something that is, well, not only on the table. Again, there's a merge request from me to be able to generate SBOMs from KDE Linux. We can do more of that. Yeah. And we already discussed that. We want to have developers, well, only spend cycles on things that matter. That's going to be super cool. And then one very important thing that we should be able to is that we can talk to our different hardware partners and say, this is the operating system that we've been testing, that we've been creating, and we suggest you deliver that to end users so that end users can have the KDE experience that KDE considers that is optimal. But that's, well, our peak. That's where we're going. That's not where we are right now. Actually, KDE Linux as a project is still on beta. So, still on beta, or it's not even beta yet. What's the difference between an alpha and a beta anyway? But yeah, we're working on it, and I think that it's really exciting. One of the reasons, maybe it's not clear in my explanation, but Flatpak and KDE Linux are more or less part of the same story, in that Flatpak is how you will be installing, or you are installing things largely on KDE Linux as you use it right now. So having them all be part of the same landscape, I think that is super important. But yeah, that's more or less what I wanted to talk about. If you have any questions, you can ask me now or send me emails if you want. That's good.
Thanks for the talk. Can you explain in a few words what BuildStream actually is? So I don't know what BuildStream is. Yeah.
Yeah. How about instead of words, we use, maybe we can look at the recipes that could make sense. I mean, in a few words is what I was talking about earlier, right? It's this solution for building that will be GitLab, free desktop. That for building applications in whatever applications, binaries, in whatever makes most sense, right? Like there's been like build system geniuses that have been thinking how they wanted to create a build tool, and they came up with a tool that, well, as I was saying, it has all of the metadata about how to build an application. It has a system of plugins so that let's look at a recipe. Components. You see components. Is there a favorite one? Haspel. This Haspel is awesome. Maybe we can just see the recipe. So what do we have here? Just like most build systems, you will say what kind of things you want to build. In this case, it's an AutoTools project. So what BuildStream will do is called /configure with, well, these variables here as arguments extra. Otherwise, it will use the default ones. And then it sends the dependencies. This one, for example, needs Perl, needs text info, and then you can add things after the install commands. So these are YAML files, but they're YAML files with some syntax sugar on top. And part of the syntax sugar is, for example, the operator here. Maybe you can make it bigger. It's going to be easier, right? And this is what this means is like you have already a list of commands here. Append the command we have here. You can, like, you're going to build them, and then you can say, like, for example, all of the .ale files will be put into the val kind of part, so that when you generate your runtime, you're not putting files that you don't want in there. So what BuildStream is doing is, well, calling the build, and then splitting the assets that it generates in meaningful ways, so that when you create the product, you can create it in a sensible manner. Like, you will be able to produce an operating system that is as small as possible, but if you want development tools, you can also add them, and so on. So you can, well, trim it and make it yours however you want. And then, well, here, for example, we're saying where we're getting it from. So it's coming from Git. It's coming from that URL. And then you say, well, this is the commit that you're building. But you can tell it to track this one. So, for example, this project, I guess that all of the tags, they start with rel. So we have tooling as well for saying, see if there's a new tag. And then it will automatically do that work and well, update this file, and then you have the latest version, which will be more stable and better because we know that that's how the world works, right? Does that make sense? Does that explain what BuildStream does? Yes. Thank you. Do you have any other questions?
All right, doesn't look that way. Then thank you, Alec. And